In this video, I'm going to be doing several problems on the 6 trig functions and how to find the exact values of them. Problem number 1. All right, if I am given this triangle, looks like this, it's a right triangle. I'm going to call this the angle that I'm talking about, or theta, and this is 6 and 8. Well, hopefully I can recognize right off the bat that this is a 6, 8, 10 right triangle because I know some things, so I'll call that 10. If you don't know that, you can always use the Pythagorean theorem, which is a squared plus b squared equals c squared, so 6 squared plus 8 squared equals c squared, and 36, 64 equals c squared, so 100 equals c squared. So there's where I get that 10 equals c. Okay? Otherwise, if you knew the Pythagorean triple, you'd be able to find that out. All right, so given that I know that, I have to find the 6 trig IDs from this triangle. So my 6 trig functions are sine, cosine, tangent, cosecant, secant, and cotangent. Sine is opposite over hypotenuse, so if this is my theta right here, then this is my opposite side, this is my adjacent side, and this would be my hypotenuse. And from here on out, it's pretty easy. Sine of theta is opposite over hypotenuse, as long as I know that. So sine is 6 over 10. Cosine is adjacent over hypotenuse, so that's 8 over 10. And tangent is opposite over adjacent, 6 over 8. Now, with the reciprocal identities, I can easily say that the cosecant is 10 over 6, the secant is 10 over 8, and the cotangent is 8 over 6. In my next problem, my triangle looks, let's say, a little bit more like this. And my theta this time will be right here. So I'm talking about this angle. And this is 9, this is 41. Now this is also a Pythagorean triple, so some of you may know what the value of this side down here is, but it's not a common one, and so I'm going to use the Pythagorean theorem to fill this out. Now this is the hypotenuse, 41, so I'm going to say, I'll call this a for right now. A squared plus b squared, which will be 9 squared, equals 41 squared. And I just realized I don't have a calculator, so finding 41 squared is not going to be as easily said. 41 times 41, 4, 1, 6, 8, 1. So that's 1, 6, 8, 1. And then I'm going to subtract 81 from both sides. And I'm going to find out that a squared equals 1600. And so therefore a has to equal 40. Now that I know that, oops, trying to use a little trick here. It's not working so well. I can replace my a with 40. So this is a 9, 40, 41. It is a Pythagorean triple. It's not one that we hear that often. So again, what's the sine of my angle? Well, sine is opposite over hypotenuse, and this is the adjacent side. So my sine must be 9 over 41. My cosine from SOHCAHTOA is adjacent over hypotenuse, so it's 40 over 41, and my tangent is opposite over adjacent, which is 9 over 40. I'm going to use my reciprocal identity knowledge to find out that the cosecant of theta is 41 over 9, the secant of theta is 41 over 40, and the cotangent of theta is 40 over 9. Okay. In my next series of problems that I'm going to do, the directions say to find the exact values of the 6 trig functions of the angle theta for each of the 2 triangles. Explain why the function values are the same. So I'm given 2 triangles. Here's one, and then I'm given a bigger one. They're both right triangles, so I get to use my right triangle trig, and the theta is right here on both triangles. So this is going to be the opposite side for this little guy, and this is going to be the adjacent side, and this is going to be the hypotenuse. And on the bigger triangle, this is the opposite, this is the adjacent, and this is the hypotenuse. The numbers that I'm given on these triangles are 3 and 1 for this triangle, and 6 and 2 for this triangle. So I've got to find the value of, let's say, we'll call this A and we'll call this B. So what's the value of A? Well, that's A squared plus 1 squared equals 3 squared. So A squared equals, let's see, the square root of 8, which is 2 root 2. So this value is 2 root 2. In the second triangle, the larger triangle, I'm going to do 2 squared plus b squared equals 6 squared. So b squared equals 32. So b equals 4 root 2. Okay? 4 root 2. If I did that a little quick, you can hit pause and try on your own to find those values, because I reduced pretty quickly there. All right, so my 6 trig functions of this little triangle. Again, the sine of theta is opposite over hypotenuse, so it's 1/3. The cosine is 2 root 2 over 3, and the tangent is 1 over 2 root 2. Now I'm not going to rationalize, but you can if you'd like. The cosecant would be 3. The secant would be 3 over 2 root 2, and the cotangent would be 2 root 2. Now in the larger triangle, the sine is 2 over 6. The cosine is 4 root 2 over 6, and the tangent is 2 over 4 root 2. If we start looking at this, and maybe it's clicking for you already, if I look at the value of like the sine, let's say, is 1/3, and this one is 2 over 6, 2 over 6 can be rewritten as 1/3, right? And the cosine, 2 root 2 over 3, if I cancel these out, I get 2 root 2 over 3. So what do we know about theta? Just thinking. Well, because the ratio is the same, even though the bigger triangle, the ratio is larger, when we boil it down, the ratios are identical, which tells me that even though triangle, we'll call this triangle B, is bigger than triangle A, this angle, this theta in both of them is the same value. One triangle is just bigger than the other. And that's, again, why the trig functions work. Because no matter how big the triangle is or how small it is, if you have, a 20-degree angle, it's always going to create the same ratio, no matter how big or how small the triangle gets.